Who knows how a differential works? 2 people. Okay. We're going to start with the bare basics, right? And I'm going to start with the board. You have a vehicle, you have 4 wheels. A differential basically is a way of turning the power, okay? On a 4-wheel drive vehicle, you have a transfer case in the middle. So the power comes off of the engine, it goes into the transmission and into the transfer case. The transfer case is a little gearbox that sends the power forward and backwards, okay? There are different types of transfer case setups. There is part-time 2-wheel drive, 4-wheel drive. There is 4-wheel drive or all-wheel drive. And then there are like selectable ones with high and low range, depending on the vehicle. Like your Subarus don't have a low range, right? Your LR2s and stuff don't have a low range. They also have a different type of transfer box set up on them called a Haldex, which is kind of like a limited slip, if I was to say it that way. But basically the power comes out of the engine, it goes into the transmission, it's still moving backwards, it goes into a transfer case, and the transfer case takes that power coming this way, it usually moves it off to the side and it sends it forward and backwards. So now your power is going here and to the front axle. Okay, at that point you now have power at the 2 ends of the car, but you don't have it to the outsides. So what they do is they put a differential in there on each axle, here and here, and what they do is they turn the power that's going forward and backwards to the sides, right? And that is done through a sun gear and a pinion gear. And if you look at this, this is a pinion shaft going forward from the drive shaft to the transfer case. So the power comes in through here, and this spins, and when you spin that, it's spinning the gear in here that's coming forward with side gear, which has side teeth on it, and it turns what's called a sun gear. And you can see it's now rotating the power this way. Now, there are many different types of differential setups, and we're going to lead into that in the next second, but the basic concept is to turn the power to the sides, okay? That is what a differential does. Now, you have what's called a carrier, and which is this assembly right here. These are examples of carriers that I brought. This is a open carrier, just like this. And I just happen to have this thing apart sitting on the table at work. So your power comes in through the sun gear on the sides, and it's bolted to this thing. Well, this thing's going to spin, okay? And this spins this way, so your power is now moving out to the axles at the wheels, okay? That is this part right here. You've now turned your power from a pinion to the sun gear and sent the power into the axles, okay? That is basically how you get your power from the engine split in different directions and to the wheels, okay? That in itself is how a vehicle moves, okay? The next thing is, how do you get it not to, you have to do something inside there, the magic, that allows each wheel to spin independently. As you go around a corner, okay, and if you know basic geometry, this turn is shorter than this turn. So this wheel on the outside edge is traveling farther than the one on the inside edge when you go around a corner. So the wheels have to travel at different speeds. The way that Land Rover does it, it's all-wheel drive, okay? Everything has power all the time, okay? There is no two-wheel drive option. It's just constant power going out to the wheels. So by doing that, your front wheels and your back wheels are also traveling at different speeds around a corner. So with that in thought, you can't have constant power sent both directions in the middle, because this is going to spin here. The shaft is going to spin different than the shaft here going around a corner. Also, the front wheels turn, which changes the speed that they work at versus the backs that are stationary, okay? So you have a lot of things moving at different speeds in there, okay? So what they do is, by having a differential here and here, this wheel can travel further than this wheel on the front, and the differential here allows this wheel to travel further than this wheel on the back, okay? In the center, should have brought the transfer case. It's sitting on the floor. I have one. In the center, you have another differential, okay? So the power goes into the transfer case. They set it sideways. There's the 3 gear sets, okay? You have your main gear set, your input gear set. You have a middle gear set, which is called the intermediate gear. And then you have your output gear sets, which have everything on it. And on the output gear set in the middle is another small differential. And that small differential allows the power going to the front and the power going to the rear to work at different speeds. As long as everything works beautifully, as long as everything is on the ground, in a perfect world, flat ground, whatever, all the power is transmitted equally to all 4 wheels. Now, we're going to take that to the next step. Once you take a wheel off of the ground in an all-wheel drive setting, so a Discovery 1 with no lockers, no traction control, anything like that, old Series, old Jeeps, once you take a wheel off of the ground, same as electricity, everything takes the shortest path of least resistance, right? So if you pick a wheel up, all of the power you pick this wheel up here, all of the power that should be going to here is being spun free by the differentials and going into the wheel that has no traction, okay? So the way you mitigate that, and the way it used to be done, is with a center diff lock, okay? Now, if you lock this tight, and that is what, you won't see it in this one because it's inside, but this is locked differential. The output of the sides spins at the equal speeds, okay? You can't differentiate. The differential is taken out of the equation, so the speed going front and back are locked and matched together, okay? So now the power going out is the same front to back. Doing that, if these 2 wheels are on the ground, this wheel comes off of the ground, the path going to the back of the car is going to go down and to the wheel with the least traction, right? It's not going to send it to the wheel that's sitting on the ground. It's going to send it the easiest way it can, which is the wheel that's off the ground. But by locking this, the front still has power going to the front. These 2 wheels are on the ground, you can still move the car. So that is called a center diff lock. And that is a locking differential in the transfer case of the car, the center of it, okay? Now, I'm going to tell you an old school, and then we're going to work in a new school. Back in the day, we didn't have lockers. They didn't, back in the early days, there was no such thing. We had differentials, but we didn't have lockers. And so before the advent of lockers, and before the advent, or even when the advent of lockers, there is, I'm gonna step into a technique thing. The wheel is up in the air and the wheel is spinning. I'm gonna talk about, like, 2 wheels are off the ground. Let's take This one here is off the ground, and this one here is off the ground, okay? Now, your center locking transfer case is locked, but your wheels, you have one wheel here and one wheel here. The path is going up and out, path is going up, down, back and out, right? Path of least resistance, you're going to go to the two wheels that are off the ground. Your car is no longer moving because this wheel has traction and this wheel has traction, but they have no power, okay? And I say no power, I'd say no force behind them, because they do have power there. There's no force to move that power. So what you do is, old school, we would pulse the brake pedal. You would basically 2-foot it, you're giving it gas, and you would tap the brake pedal a bunch of times. You're putting a little resistance on this wheel and this wheel, or all the wheels at the same time, basically, with your brake pedal on there. But what it's doing is it's jarring this one to stop and sending the power across. And same thing here. It's jarring this one to stop and sending the power across. It'll allow you to not fully overcome a obstacle, but to keep the car edging till you can get a wheel back on the ground. Most of the time when your wheels are off the ground under mild off-roading, the car can be moved forward by doing that, and just get enough so you have two wheels gain traction on a matched axle and you can keep moving, okay? That is a very old school trick. It works like a charm. Unbelievably, it works really, really well, okay? And most people have forgotten that. It's a technique that is now absent of the world because we have traction control and lockers and all of that stuff, but it does work. I'm going to give you guys a little tech tip, driving tip. The drop off on Pinion Mountain, huge drop off, right, John?
Yeah.
Scary as hell. I've done it multiple times, and every time I get to the bottom of the hill and I'm standing there looking at it and looking at my line I'm going to take, and both times I'd say I better go up and do this before I chicken out, right? It's a steep hill, and there's a trick to it though, and a friend of mine taught me this years and years and years ago. When you go and drop into it, if you grab the emergency brake and hold the button, you can yank the emergency brake just like tapping the brake pedal, but you can yank and jerk the emergency brake to keep the car from sliding around as you're going down this hill. It's a really steep hill. It's really rutted out. More than once you have a tire, 5 feet off the ground. It's a pretty intimidating hill. But the trick is, on hills like that, you can use the exact opposite thing. Just grab the emergency brake and yank on it. When you're going down a hill, the car wants to slide around if you hit the brakes, right? It wants to spin the back of the car around to the front, so because it has less weight on it. By pulling that, it kind of keeps things nice, and you just pull and release, pull and release, pull and release. It'll straighten it back out. So that is how basic differentials all-wheel drive work, okay? I'm going to step over and we're going to talk about lockers and limited slips. A locker fully locks the wheels together. There are 3 basic types of lockers, and then there is a limited slip style, okay? So there's technically 4 ways of doing this. You have the old school is Detroit and Eaton, okay? They've been around forever. The Eaton is a limited slip differential. The Detroit is a full locker. They're very aggressive, but the Detroit works, I should say, Detroit is very aggressive. The Eaton LSDs are very mild, okay? And LSD is a limited slip differential. It is a helical gear that spools when the wheels start spinning. It starts to spool tighter, okay? And that will slow that wheel down and transfer the power back in. LSDs are phenomenal on the front of a car where you have to turn, because you can't fully lock it, otherwise you can't turn. Both wheels have to spin at different speeds. So you don't lock the front, you don't run a full locker in the front on road, you run an LSD in the front. On the back, you can run a full locker, and so you could run like an Eaton, Eaton LSDs, or sorry, Eaton, sorry about that. You can run a Detroit, you can run an air locker, you can run an e-locker is the newest thing that everybody's come out with. So there's features and benefits of each way of doing lockers, okay? The locker is there to stop the wheels from spinning at different speeds, okay? By doing that, you have traction. Even if this wheel's the only wheel on the ground, if you have a locker in there, that wheel's going to push the car, okay? Same with an LSD. If, let's say, you just have one wheel on the ground, the LSD will eventually spool up, stop the other wheel, and move the wheel that has the traction. So the three different type of lockers, 4 different type of lockers are an air locker. An air locker requires a compressor. It requires lines. It requires electronics to the solenoids. It requires switches. There are a lot of components that go into an air locker system, but what it does is it compresses air into the housing to basically lock and engage the teeth together in there, and so that both outputs are the same at the axles. And what it's doing is it is moving this, these are freaking heavy. It's moving this forward, and the center in here where the axle goes in is locked together, okay? So there's no differentiation in speed to one wheel or the other. Doesn't matter if a wheel's off the ground or on the ground, it's going to move it, okay? With a air locker, what it's doing is it is compressing air into the mechanism and locking the mechanism together. An e-locker or electronic locker will do the same thing. Now, you've eliminated all of the air compressor and all the lines out of there. You just have a switch wiring down to the e-locker, and so you're cutting out a lot of extra failure points to a system. By putting in an e-locker, it is selectable. You can turn them on and off. An air locker, an e-locker, you can turn them on and off. Hit a button, it's locked. Turn it off, unlocked. It's about that simple. An e-locker will send electricity down to this, and basically the same thing, lock the differential together. And then this is a Detroit locker in this one. A Detroit locker is a mechanical locker. There's no buttons, there's no switches, there's no way to control it at all. It will allow overrun of the outside wheel when you turn, okay? Most of the time. And this is why lockers, an e-locker, or sorry, a Detroit locker, usually you want to have heavy duty axles, especially if you run it on the road, or if you're in the rocks. But basically there's a lot of shock in that assembly because the locker is always locked, but it allows it to overrun, and it's basically a bunch of teeth, and it allows it to do this. And so a lot of times people complain about a Detroit locker banging, like, and when they bang, man, it feels like somebody ran into the back of your car. It's that violent of a bang usually. The new ones are much better. They don't do it as much. I almost never feel it in mine. But when you first put them in there, oh yeah, you go around a parking lot and you'll go to straighten out, all of a sudden it engages. Bam! You know, and you feel it. But there is no thought input. It's doing its thing. You don't have to touch a thing. It's always there. So a Detroit locker is a mechanical locker versus the other ones, which are electronic and air operated. It is always there to do its job, but you have to know that when you're driving it on the road, that it is always there doing its job. So they can engage and disengage on you, and you feel it. An LSD on there, and the reason why we use them in the front, if you go around a tight corner with it locked, and I had I had a K5 Blazer that was fully locked with the little locking hubs on the end to lock the axles together. So we were doing switchbacks up this mountain, and we were rock crawling up this switchbacks. I couldn't turn the switchbacks, so I would get to the end of the straight part, I would unlock a hub so I could make the turn in two-wheel drive, go around the corner, and I'd get out and lock it back in so I could climb the rest of the next section. You never want to have a full locker in the front, right? If I had an LSD, the LSD will allow you to turn the wheel and make the corner. Air lockers and e-lockers, you don't have to even worry about it. You get to something like that, you can pick, okay, let's lock the rear, but leave the front unlocked, or you get to the corner, you push the button, unlocked, you know, and you can go around the corner. When you go around a corner, or try to go around a corner with a full locker in the car, in the front and the rear, when the front is locked, the car will push straight. It will not turn. It doesn't matter if you turn your wheel, both wheels are spinning at the same speed, is going to push the car straight, and you're not going to be able to make that turn. It takes a lot of force to drag it around the side, and the only way to do it is really to spin the tires. So the little Chinese Rhino there is full locker, and yeah, you go around, just going like around there, you got to kind of romp on it to make the turns. In the driveway, it doesn't want to turn very well at all. So those are all the different types of lockers, what their benefits, what their downfalls are. And now with the advent of traction control, you no longer need, to most respects, lockers, okay? The car is doing it for you by computer. But we're gonna go into this a little bit more here. I want everybody to take a look at these. This, and you can spin it, this is your differential. This is called the spider gears, and this is what allows everything to turn at different speeds. So the whole thing, we just take this out. Okay, so this is all your spider gears, and this is what's in the differential on an open differential. Basically what it's doing is it is spinning all of the gears together, and if you see when I spin it, my hands move at they move back different, they move different directions, right? So if you spin them both forward, they're not going to turn, but it allows everything to move at different speeds at the wheels, okay? And let me set this in here, and I can kind of show you, even though you can only see one side. So by doing this, if this carrier is moving this way, okay, but you need the wheel on the outside to spin faster, it can move at different speeds. So everything can rotate, you know, it only works if it's all on solid ground, but you can move this at a different speed than this. So it all goes together, you know, it's all separate, right? It all can move at different speeds, any rotation. Now I'm rotating this direction. You can't see it inside here, but this side, if I go this way, is spinning the opposite direction, okay? That is an open differential. This is an open differential. This is a locker. And basically the locker has it's not open in the middle. It's got something in there to keep it, the spider gears are missing, so it can't differentiate back and forth. The only way it does that is by releasing the locker. And then there is usually a spider gear or some kind of piece in there that allows it to move at different speeds. The way that the Detroits do it is it's toothed and sprung, so it allows it to ratchet around each other, right? Let me get to my. Okay, that in a nutshell, we've got how a differential works. Okay, gear ratios.
Quick question.
Yes. Does anybody have any questions? We'll start with you.
I have an F-250 two-wheel drive.
Yeah.
And the Ford place put in the wrong rear fluid.
Okay.
And I ended up replacing the differential.
Yes.
Why?
The wrong fluid causing it probably F-250.
Yeah.
Probably has a limited slip rear end in there.
Yeah.
Okay, so limited slip rear ends require basically a certain type of additive to them, and otherwise it tears apart the like clutches. So that's probably what happened, is by putting in the wrong fluid, it didn't have any additive in it.
Yeah, that's.
Yeah. And it'll wear the gears and everything. You know, depending on the fluid that was in there, you could have excessive gear wear. Anybody with old Land Rovers, you put it in gear and you hear that clunking. I'll get to that. But basically, if you can put the wrong fluid in something and it'll cause excessive wear, especially if it has some type of locker in there, or an LSD. The factory LSDs especially require special fluids for them. So your transfer cases on all of your newer cars have clutches in them, and so those clutches require a special fluid to keep them going. You know, and it's expensive. I think it's $100 a bottle. Luckily they only take 2, but it's like $100 a bottle for the clutch for the transfer cases on these things. Okay, let's go to gear ratios.
Question?
Oh, yes.
You mentioned that these limited slip differentials have to spin up. I didn't explain that. What does that mean?
Okay, so it's a helical gear set. So, thank you. Anything you guys have questions on, tell me, ask, because if I miss something, somebody out there is not going to get it, right? If you have a question, then you should ask so that we can cover it.
Can you repeat the question?
Huh?
Can you repeat the question?
The question is, basically, how does an LSD work? When I said spool up, so it really does spool up. And what happens is it's a helical gear set. So the gears are more like a worm gear, and the more that the wheel spins, the tighter they contract, if that's the best way to describe it. So the more that the one extra wheel, the wheel that's spinning is moving, it's basically ratcheting the gears tighter, and that's so it'll keep eventually stop that wheel from moving, and by binding up the center.
Synchronize.
Huh?
It'll synchronize the wheel.
Correct. Very good work. Yeah. Any other questions? Okay. I'm gonna say one thing, and this is gonna sound funny, but any two-wheel drive truck is one-wheel drive. This is gonna sound really funny. Any four-wheel drive car is only two-wheel drive. And I'm saying this as, in a front-wheel drive car, and if you ever look at a burnout on a street, right, on a rear-wheel drive car, right, you guys, you always see there's a guy over here. There's a section of pavement on my on the dirt road over here, and you could see somebody with a posse in the back laid a big old, you know, line down the road. He was locked in the rear. But a rear-wheel drive car, if you ever do a burnout, will always spin the right rear tire because of the way that the force is delivered into the back axle. Even though it's the differential and it's got, you know, it's the power's always going to go to the right rear, and in the front wheel drive it's always going to go to the left front. Okay, don't ask me completely why. It is the physics of that thing that does it. But an all-wheel drive, a four-wheel drive car is two-wheel drive, and a two-wheel drive car is one-wheel drive, and a four-wheel drive car is two-wheel drive. And not until you put lockers in it is it actually four-wheel drive, okay, or traction control.
So the simple sentence among us, is it safe to say that the center diff splits 4.5 power half, and then the front and back diff split power left to right?
Correct.
Okay.
Yeah. The purpose of a differential, it has multiple purposes, but the main purpose of it is to turn the power. It's got to turn it because it's going, your engine's forward and backwards, you know, for most cars. So it has to turn the power to the side. And so that's why you put a differential in there, is to turn that power. The secondary thing is to offset so the wheels spin at different speeds to go around a corner. Okay. There is one other type of locker, and we just touched on it a smidge, but there is a thing called a spool, and that is technically none of this is there except for it's a solid assembly with the spider gear and the pinion gear in there in the differential. There is no differentiating it at all. It's something for complete drag strip. Car can only go straight, absolutely only go straight with a spool in it. And so it is out there. It is not something we deal with unless you're drag racing, right? But there is a thing called a spool, and it does no differentiation at all. It cannot turn a corner. Okay. So the next thing we want to, any other questions? Okay, let's talk a little bit about gear ratios. Gear ratios can be changed in a few different places on the car, but are mainly done at the differentials and the transfer case. Transfer case will change the whole ratio of the drivetrain from the transmission back, right? It is usually the most expensive and the most difficult way to change gear ratios. And so a lot of people do it at the axles or the differentials, front and rear, because you're usually doing it when you do a locker, you know, and you're doing it for a reason. You're going to go rock crawling, or you need a little bit better gearing. You put big tires on the car, so it's usually really economical to do it at the differential by changing this gear and your pinion gear. And basically, this here this is massive. This is a 584. Most Land Rovers, I think even the LR3s, LR4s, I think they're all 354 gearing, if I remember correctly. I know that all the Discoveries, Classics, Defenders, everything pretty much came with 354s in it. It's a 3.54 gear ratio. The gear ratio is how many times does this turn for one rotation here? Okay, so 3.54 turns this one time. The next gear ratio, there's 350, there's all different kinds, and they go up. The biggest you can put in the standard differential, and not that big, the big ones, but the regular differential, is 471s. A 471, and this is like, is crazy, right? It's a big gear ratio for a regular Land Rover. I have 471s on Annabelle. My top speed is 65 miles an hour. Doesn't matter what I'm doing 65 miles an hour, right? That's as fast as that car will push, and yeah, can it go faster? Yeah, I'm pushing the engine. But the nice, comfortable cruise speed freeway, it isn't going to do 70, 75, 85. It won't go there. A 354 in the same car, 80, 90, 100 miles an hour. So gear ratios transmit the power differently, like so you can have more efficient use of the power. I don't need to go 70, 80 miles an hour in a rock crawler, right? I need to do 50, 60 miles an hour. I just, as long as I can get on the freeway and get where I'm going, I'm not going in there for a race, right? Now, the reason you do that is my power torque to the wheels is greater because I've changed the ratio that the power is being transmitted at. And so I have more force on the lower end of the scale, right? I have more power to turn the bigger tires on, and wheels on there. So gear ratios can be changed. Anytime you put a bigger tire on them, it's not necessary, right? It's not necessary unless you really have to, right? And usually it's more for getting into the rocks, climbing those big, steep hills, things like that. That's when you want to have a little more oomph, a little lower gear ratio. You put some great big tire on there. You need to get your back to normal size power ratio at the axles. You can change the gear ratios on there at the axles, at the differentials, and regain that normal power. Okay. So I did touch earlier the clunking noise. You hear that? We have a lot of gears in Land Rovers. That's just one of them, right? So you have one gear there. You now have a gear at the transfer case, the differential there. You also have the input to the output shaft, the intermediate shaft to the output shaft gear. It's going to have a little play. You have the input shaft to the intermediate shaft. You're going to have a little play. You have the input shaft from the transmission. You're going to have a little play. Now I have the front differential in there. You have a lot of play in the differentials on there, and so yeah, a lot of times on the older stuff, we would always get people complain of clunks, when they put the car in gear or go from forward to reverse or whatever. It's basically this. Every one of them has to have a little bit of play. You can't mesh them up tight, otherwise they just, it'll just wear each other, right? So that's just a nice example of how much play. I mean, there's enough you can hear it. Let's go on to the next thing. So we covered gear. Anybody have any questions on gearing?
How big a change in tires before you really need to consider the change in the differential?
Depends on really what you're going to do with the car. Most people, 33-inch tires, you don't really have to change the gear ratios until you start feeling like you're losing the power climbing a hill. That's when you need to really change it. It does, by changing the gear ratio, put a lot less strain on everything in front of it, okay? Because it doesn't have to work as hard to spin those tires, okay? So usually, on older cars, don't have a ton of power. 33s, you probably want to start changing. 35s definitely need to change. You don't realize how much power is lost in the tires themselves rotating them. So on all of these new cars, you don't even have to worry about it. You have plenty of power to be able to turn the wheels on the car and not worry about changing gear ratios. They don't even make a lot of I don't even think they make gears for any of the new stuff. I haven't seen any of it out there. And I looked. I was looking for my sport. I wanted to change the gear ratios, and they don't make it. They do make lockers. They are very obscure, hard to get. but they do make lockers for LR3s, LR4s. They make ARB makes an air locker for them.
Is that center?
Front and rear.
Front and rear.
Front and rear diffs, yeah.
Center-
David Ikeda's has front and rear lockers in it.
So on the newer stuff, 05 and newer, is center always included if it's got low range?
No. That's I don't think so. Some of them don't even have low range in the center anymore.
Well, the ones that do have low range, does it have a center automatically?
I can't answer that on all of the new ones.
'Cause wouldn't that be
I
more safe
think
with low range?
I want to say yes, they do have center locking diff on all of them. The back is the one that we don't know. You have to see if it's in there.
Yeah, because that's the HD package.
Yeah,
Oh,
the
okay.
HD package. As far as I know, I'm just going to say this. As far as tire size to gear ratio, like 33s, somewhere around a 411 brings you back to stock. And so a 433 or 435 area will put you a little bit better crawl ratio on a 33. I want to say like 35s bringing it back to stock is a 430 roughly gear ratio on there. I'm running 33s on 471s, and like I said, it's way overkill. You know, but the car's not meant to be on the street for the most part. Let's see, we talked about that. Okay. Let's jump to traction control. Technology is phenomenal. Traction control is a factory's way of locking the differentials, technically. So, and we will touch base on the center locking. We talked about the path of least resistance. We've got a wheel that goes up in the air, and all of the power in the car wants to go to that wheel. There is another way to mitigate it from going to that wheel, and that's by stopping the wheel. Okay? Somebody had the great idea years ago. We had ABS. Okay? ABS is a computer operated way of releasing the brake and pulsating the brake fluid, basically the brake pedal, to a wheel that locks up. Reverse that and you have traction control. Okay, simplest thing in the world. We already had ABS. Okay, so what happens is when you step on the brakes really hard, if the back end, and the reason why most vehicles back in the day when it first started, it was used only on the rear of the car. The rear, if you lock up, when you hit the brakes, all the weight is now on the front wheels. Okay. By doing that, the back of the car is unloaded. If the back brakes lock up, the back slides around. Old technology and old school thinking, they didn't put as much power to the rear brakes through a proportioning valve. The proportioning valve limits the amount of braking power going to the rear and puts a lot more force on the front. Also why cars had drum brakes in the rear and disc brakes in the front. New technology, you can actually balance the whole thing out. They still limit the power to the rear just so it doesn't lock up and engage, but you can now run a much more balanced braking system with the new technology. So the ABS, what it would do is when the wheel in the back stops and the front's still going, okay, and so the car won't slide around, it pulses the brake pedal and releases the brakes in the rear from locking. Okay, that's old school, kind of mid school. The newer advent of it with four-wheel ABS means that any wheel can be controlled by the braking system, by the ABS system. So as you brake, you going down a dirt road, you hit the brakes, the front wheel starts to slide. It releases the brake on that, and actually what it's doing is it's pulsating the fluid to that to vary and basically let the wheel keep moving, allowing you to be still in control of the vehicle. If you've ever slidden on ice or snow or whatever, if you ever gone hydroplane, you hit the brakes and the car is sliding, you turn the wheel trying to miss something, you're still going straight. It isn't going to turn. So the ABS, by doing that, allows the wheels to continue to roll and keeps you in the steering control of the vehicle, and also keeps the car roll in tracking forward to backwards and not doing this. Okay, so that is ABS. Now that we have ABS on all four wheels, why not reverse the technology? It's very simple, it's already there. So traction control is the reverse of that. Your wheel starts spinning because all the power is going to the wheel with no traction. Put the brake, the traction control system, which is the ABS system, again, it's the same thing. Now we've applied the brake here, and the power goes back into the system. Power is now being transferred here, across. You can take, on a traction control system, you can take 3 wheels off the ground, and you can still move the car on that one wheel. The car is smart enough, the Land Rover is phenomenal with this. The car is smart enough to figure out one wheel. I have had both front wheels off of a ledge, the left rear sitting in a mud pit in a stream bed, and the right rear was the only wheel on the ground. And you sit there, you step on the gas. Do not touch the brake. Many people touch the brake, turns off the traction control, and turns on ABS. You're going from one system to the other. The minute you introduce that brake pedal, you're now taking control of the braking system and turning off the traction control, turning on the ABS. So you lightly step on the gas, and I say lightly, and you let the computer figure it out. Now, back in the early discovery, the 2 days when we started with this, you could take some time. You're sitting there wondering what it's doing. Well, it's thinking. It's applying the brake here, applying the brake here, applying the brake here, applying the brake here. Throwing these two, throwing those two. It'll start figuring it out, right? And it seems like eternity, and most people don't have the patience to wait, but you don't want to over rev the engine. You want to just keep it figuring it out. Wait for it to start to grab that wheel, a little bit more gas, let it push itself, and it'll figure it out. It pushed me over that ledge and got me back, got me moving again. The newer cars, the computers are so much faster that they figure it out really quick. Just the advent difference between Discovery 2 and LR3 Sports, the technology was majorly refined. And I immediately caught it when we were doing the wheels events. I immediately caught it because I had to drive customers' D2s up things, the LR3s that were just driving up. And it just basically, the technology, the computer, the ability of the computer got a lot quicker and a lot more efficient with it. So the traction control basically means that we can now have 3 open dips, and we can retain the all-wheel drive, and we don't need the lockers in there per se for most things. Okay, the thing that traction control cannot mitigate, it has its limitation, and this is why they put back and they put locking rear diffs and center lockers in the cars is because traction control cannot figure out when all four wheels are spinning at different speeds. Soft sand, mud, okay? It cannot tell this wheel's spinning at 10 miles an hour, this one's spinning at 20 miles an hour, this one's spinning at 5 miles an hour, and this one's spinning at 30 miles an hour, because all the open diffs, the power's going everywhere, right? So it starts just throwing it out, but every single wheel doesn't have traction. It can't figure that out, right? It actually hinders the movement of the car because it can't figure it out. So what they did is the LR3s, all of the cars have a center locking transfer case. They all do. They have a center locking transfer case that allows the wheel output to go forward and backwards. Still, you need to have, for those situations, a rear locking diff. And so if you get the cars with the HD package, with the rear locker in there, that's kind of the key to those types of situations. And where it's the extreme point of it the car has trouble with. We had problems with people in Big Bear on ice, and they say my car's stuck in the parking lot and I can't move it. Okay, you know what I would tell them? Shove the car sideways. Have somebody just push the car while you accelerate. Sideways, not forward, sideways. Worked like a charm. You just move the car over, because it's sitting on a sheet of ice, right? You move the car over a little bit, and you can just shove the car sideways while the wheels are spinning, and it would gain traction. The computer would figure it out, it'd do its thing, and you'd be on your way. But I used to get this call at the dealership, I can't move my car, and the car was not moving. But yeah, so that is the limitation to traction control, and why you still need to have lockers to some extent under some conditions. Now, lockers are not are the extreme answer to the situation, right? They are not.
I got a comment. You know, I got the Doer 2020 Sport.
Yeah.
And it has a little display. It comes up. It shows you what's happening with your wheels, and it shows the center differential and the rear, and it shows a lock next to it. And most of the time I'm off-roading, it's unlocked.
Yes.
You know, and every once in a while this one will click. You know, and then maybe sometimes both click, but it's most of the time it's still out with open locks.
Because it doesn't need to have them engaged. And honestly, majority of people, 99% of the time, don't need a locker.
It's just reinforcing your point.
Yeah, yeah. It doesn't. It's the extreme where a locker comes into play, and is more of a necessity. And even at that, how quickly does it shut off?
Right away. Yeah.
So I mean, it goes back to very, very, very beginning of the whole conversation. No lockers, open diffs, old school. You tap the brake pedal, and you've just overcome that obstacle that it was engaging the locker for, right? It just takes a little bit sometimes just to move the car forward to get it traction.
And to your point, both of your points, like it's different. That rate of locking and unlocking is different based on the modes, because you remember how you said that
yes.
You can't figure out if you're in sand and everything's going versus in rock crawl versus that. The car is smart enough to, you know, figure out what you're doing based on that selection.
Yeah, and I'll say this on that: the traction control system is always on. It's always in there. It's always working. Doesn't matter what you know, unless you turn off the HDC, I think, and even then it's still working. So the traction control is always working underlying on everything, and you don't even know it's doing it. You hit a white line on a road and the wheel spins, and all of a sudden you get the little buzz and the light comes on. That was your traction control system. Just it slipped on the white line. It didn't know what it was slipping on. It just saw a wheel spin faster than it should. So it was, oh wait, let me grab that. you know. It thinks for itself. It's all computerized. I'm going to step back over to a little side note on there. While I'm thinking about it, climbing hills, you want to turn sometimes the HDC, the hill descent, not HDC, traction control,
Dynamic stability.
the DSC, sorry, DSC. You want to turn off DSC, okay? Especially if it's not just a straight hill. We had one up in Big Bear years ago. We were leading a wheels event, and the trail kind of went like this around a tree, and then it came up around a rock and went up onto a shelf, okay? And people were not making it. They were having to back down because the car wasn't climbing the hill. And what it is the dynamic stability control, DSC, cuts engine injector pulse, engine horsepower, to regain control of the car in the event that you are going into a corner too hard, okay? It doesn't know what you're really doing with it, so when you go around that tree and you go around that rock, the yaw rate sensors in the steering wheel, it's telling the car you're throwing it into a corner and it's sliding, right? The traction control's on, the DSC is starting to engage, and you're cutting power and you're not climbing the hill. So the trick is you push the DSC button and shut it off. If you hold that DSC button for 10 seconds, I think it shuts the whole system down from engaging. I don't know that you need to do that. I think you just need to hit the DSC button to keep it from seeing those yaw rate sensors and cutting engine horsepower. And it does work though. Also, coming out from Julian, those windy roads, I overpushed an LR3 I was driving, and yeah, I went a little too hard through the corner, and
Will that happen if you got a heavy load on top, like a rooftop?
Absolutely.
Because I remember when I had my rooftop deck, that thing would come out all the time.
yes. So things that affect the dynamic stability control and LR3s, even Discoveries, Ace Car Discoveries had it. They have yaw rate sensors, just like you would in an airplane. They have yaw rate sensors. I think there's one in the headliner, and then there's one at the bottom of the car to tell how hard you're cornering into the corners, and how much sway and all of that stuff that the car is doing. It's telling the computers what you're doing with the vehicle and whether it should engage DSC, and help with the traction control, figure all that stuff out. It's pretty intuitive on its own to do everything it needs for you. We are putting it off-road into an extreme condition, and sometimes you have limitations to what it can tell that you're doing with it. So there's tricks around a lot of that stuff when you do run into it. Any other questions? Okay.
I have one.
Yep.
Is there a book?
On what I'm teaching you?
Yes.
Absolutely not.
But there will be a video.
You could read 100 books, you could study it in a lifetime, and you can probably spend years as a mechanic, and you probably get there. Super important. How not to break things. Who went on the trip last week?
Last week?
Broke axle?
Not mine.
Not yours, but you guys broke an axle out
Yeah.
there. Okay. How not to break things. Hey, go. So the most common failure point is there's always a weakest point to the system. I should start there, right? When you build a vehicle, all you're doing is moving weak points. So weak points. A matter of fact, weak points are usually engineered into the car. They're usually engineered into parts that are more easily and cheaper to replace. In the old days, we had wasted axles. So your axle shaft going out to the wheel would have, usually towards the end, and this is a major exaggeration, but you would have a section of it that is narrower than the rest of the axle. That is an engineered weak point in there. It's made just to break, right? So the engineered weak points, axles are very common to have a wasted spot where it's narrowed to create a weak point so that you don't break the things further up from it. A fuse is exactly what it is. It's a fused point where it's a weaker point. So I, in my Discovery 2, broke spider gears. That was the weakest point that I found in that thing, was the spider gears. I would shatter them, send pieces out. The older classics and stuff like that, you know, I dragged a car for, well, I dragged him for I think 4.5 hours, and then Eddie took over for like another 3.5 hours. But we dragged a classic that broke both front and rear spider gears. They're hanging out the casings of the differential. That is a weak point in the system. And so you upgrade your gears, putting a locker in there and getting rid of the spider gears, okay, creates a stronger point there. Where's the next weaker point? Axles, put beefier axles in there. Where's the next weaker point? Now we've moved it over to the drive shaft, okay? And so your drive shaft, and we beef that up, okay, now it's weak points at the transfer case. You know, eventually you just work your way forward. But how not to break things, and this comes up a lot. Done it myself a million times. I got rid of my nice fancy car because all I did was break it. So I went back to a D1. So when you're going over rocks, or you're going in a spot where you are losing traction, right? Driving too fast, break things. Too much throttle, break things. Too much wheel spin, break things. It's all about balance. It's all about being smooth, thinking about what's happening and how it's going to happen. You got to think ahead, because what breaks things is not, it's the inertia thing. Like, you're moving something, right? You're moving a wheel. The wheel is spinning. What happens when that wheel stops? Is the part behind it strong enough to take that impact? Not the wheel, not the tire, but the axle, the differential, the drive shaft. So, with traction control, a wheel will spin. The traction control is now engaging, right? And you're trying to give it more gas because you want to move, right? Well, you're giving it a lot of gas. The wheels start to move forward that have traction. Now that wheel that's spinning, it's being slowed down with the traction control, but it's spinning, and you're giving it so much gas. The minute it touches ground, gains traction, is when you break things. That's how you break things. So it's the slow and steady type thing. You got to let the computer do its thing and not overpower the system to do its thing. You have to trust that the computer will figure out the traction on there and apply that, slow that down, and send the power into the wheels that have traction and move you forward.
That's got to be hard to do with a supercharged.
It's not. It takes practice. It takes time. I break things. I don't drive cars with independent suspension off road because I break them. The CV joints and in the axles, they can't handle power. They can't handle the type of off-roading I do. Right? Can I beef those parts up? Yes, and it gets really expensive. So I went back to a D1. D2s, I can beat them up all day long, and you know, if they break, it's cheap and easy to fix, or I've, you know, spend way too much money on the cars anyways. So you need to, it comes with experience. Are you rock crawling it? No. Are you going to run into a spot where you got the wheel up in the air? Now you're going to think, okay, am I giving it too much power? Because I've already told you this. What to watch out for. You got to think. Don't give it too much power at first. Let it try to figure it out. Take it easy. When I first got my Sport, we were up at Cleghorn, and I saw this hill, and it's raining. It's snow. It was snowing and hailing on us, right, in the end here. But it was raining. We were playing in the mud. I saw this hill, and I'm like, I'm going to drive up that. Brand new Sports. I've had it for 2 months. Supercharged, 5-liter. And I've got the off-road tires and lift and all that. And I go up this hill, and it's got 2 ruts. One here and one here. And so I went up, 2 tires off the ground. No, don't make it. Try it again. No, don't make it. Back down. Shut off traction or the dynamic stability control. Try it again. No, don't make it. At some point, your brain should have said, I'm not going to make this, right? No. 7th time in, I'm full throttle, romping up this thing, and I made it.
500 horsepower.
I made it. The left front tire hit the ground and got traction and sent, as I watched, sparks and metal fly out the side of the car. That axle, not only did I break the axle, the axle was gone, right? I bent the pinion shaft in the differential. It was that much power I put into that wheel.
Yeah.
7th time trying this, and I should have not. And that was just one of many times I broke that car, that axle specifically. But I broke that car and towed it home. That car got a lot of trips on AAA. I would see things that I would normally go and say, oh, I could do that, and then I would go do it, and they would spit the axle out. Right? It was just didn't like being 500 horsepower.
Right.
So that is one thing you got to think about is, okay, the other thing that you have to think about on the newer cars with independent suspension is angles. We have a wheel. We now have an axle, and the axle is not straight, okay? And there is a reason, if you look at it on the car, they're never straight. They have to have an angle to them. You'll wear flat spots in it, basically. Everything should move at different phasing is the word. And we deal with that with drive shafts. A CV joint, mind you, this is all simplified. Can you guys see this? Am I not drawing big enough?
I've got one in my car if you want.
You want me to take it apart?
I got a new one.
Okay. A U-joint has to be phased. Has to have phasing. Phasing is the input and output speeds that the drive shaft rotates at. So if this goes like this, and this goes like this, and this goes into the transfer case, the speed that these are rotating at is different than the speed that this is rotating at, because this is straight and this is turned. So phasing is a U-joint here and a U-joint here. This U-joint should be traveling at the same angle that this joint is coming out at, so that this joint and this joint are driving at the same speeds. That is phasing, okay? With the design of a CV joint, a constant velocity joint versus a U joint, you're no longer dealing with phasing. You still have to keep it off center, but you're not dealing with the vibrations that can come in a U joint because it's stationary, it doesn't move. You can easily get vibrations on this induced because they're moving at different speeds, right? So you put input and output phasing on there, takes care of the vibrations. It is a crazy game that you can play and play to get it right? With a CV joint, there's another CV joint here. You're no longer dealing with phasing because the axle can move. The pieces that are rotating on their own plane. And the way they do that, try to draw this bigger. It's got bearings in there, two different styles. You have ones with like 5 bearings, 6 bearings in there, and they're all around. The axle is moving inside those bearings, and so it doesn't matter what the phasing is on it. So you get a lot less chances of causing a vibration, and usually you can tell when a CV joint is bad by a pulsation when accelerating, right? Same with drive shafts. But, or you have this one that's like a triangle. It's got three of these. So that it's basically got one of these, but it's only 3, and they're moving inside that shaft area of the axle. Basically, it can sit like this. The axle is straight on it, and it's still rotating. It doesn't matter. It doesn't have phasing. The problem with that is now you got these small pieces. Okay, you got extra moving parts, so you lose a lot of strength in the little shafts, right? And you can break them. What I was breaking was the housing that the CV rode in would snap. I would shatter them. And pieces just, there's a lot more pieces, right? The more pieces you have, the more things there are to break. So so with the new cars, you got to think about those CV shafts and the rotation, the speed that things touch at, right? When you hit the ground with your traction, where's that traction going to put its power, right? Is it going to go into the ground, or are you going to break something? So you want to take things easier when you're in those situations where you don't have traction and you're going to get traction on those wheels, right? The other thing that we were dealing with is this angle. The more that you move it off of its plane, you're tilting this. So when it's touching the edges, and you're really weak when you do that, okay? So what was I gonna say? So when you lift the car, your axles are much weaker than when it's lowered. So if you're gonna do something and push it, if you can, lower the car. Actually, on an independent suspension with the air suspension, lower the car. If you can do it and still make the obstacle, the lowest setting is the best setting. Okay. The LR3s, LR4s, lift kit, SYA kit, once you get over the limit of the, I think it's 4 inches of lift. So you get 2 inches on the springs, 2 inches on the SYA kit. If you're running a really heavy rig, that is how we have to mitigate the load on there to keep it up high, right? You have so much weight, you're squishing it down. So if you put just the spring, heavy duty springs on there, your 2-inch lift is now maybe a stock height or an inch lift, right? So you put the SYA kit on there. The SYA kit comes with limit straps on the front and the back. Back isn't really necessary. The axles are really long. You don't have that much, by doing that, you don't have that much angle. By making this shaft longer, your angle is no longer as great. The front left axle, the front right axle is longer. The differential is on the left-hand side of the car. So the front axle comes across, goes out a ways, and then it goes down. It's a longer axle, a lot less to deal with. The front left axle is the shortest axle on the car. It has the greatest, once you get to that 4-inch mark, it's really weak. So you break that axle. I broke that axle over and over and over again. So you got to be really careful, and you have to run with the lift on the LR3s and LR4s sports, all of them. You have to run the limit straps on there to keep that from over flexing. You're really limited on how far you can go up because of the length of that axle. So the other thing that I think comes into play on it is, again, the physics of a differential. Your 4-wheel drive car is 2-wheel drive. It's the right rear and the left front. So you're going to break that left front axle. It's going to break the left front axle. So you got to be careful with your throttle, basically, and think about where that tire is going to go on any of the tires. Where is that power going to stop? Okay. The thing about a full locker is all 4 wheels are moving at the same speed. So if the right front's moving at 10 miles an hour, the left front is moving at 10 miles an hour. If you're fully locked with lockers, now all 4 wheels are moving at 10 miles an hour. So if the car is moving forward, when that one wheel hits traction, it's already moving at the same speed as the other wheels. So it's a little bit less aggressive than using a traction control system where it's required for the wheel to spin for it to send the power back through. Okay. You still have to think about power management and how much throttle you put into things because things still break. Okay, any questions?
How do you tell what you have?
Huh?
How do you tell what's on your car?
Specs. It's a good question. On Annabelle, I'm going to say Annabelle and one other Discovery, open diff. Open diff, like I showed you with the differential, to tell if there's a locker in there. You're going to know if it has an air locker, or you'll see wires coming out for an e-locker. You'll see an air line going into the differential for an air locker. But if you don't have, like the red Discovery, wherever it is, we didn't know how to locker in it until I saw him romping a hill and both tires are spinning at the same speed. I see rooster tails coming out the back. Hey, wait, that thing's got a locker in it. We didn't even know we bought a car with a locker. So the only way to tell if it's got a limited slip or like Detroit, a true locker, is to jack up both rear wheels and you spin them. If it has an open diff, the wheel on the opposite side will spin the opposite direction. Okay, so you spin one wheel forward, You'll look over on the other side, the wheel's going backwards on the other side. That is an open diff. A limited slip, you spin the wheel, you're going to feel resistance, and eventually that other wheel is going to start spinning along with it. And a full locker, you spin wheel forward, other wheel spins forward. It's locked, right? It's got like a Detroit in there. There's a bunch of different manufacturers that make lockers and limited slips. I've always gone old school. They've been around forever. Detroit, Eaton, they're the oldest in the book, so I've always personally just stuck with those two. Okay, any more questions? Does that answer that question? Okay. Other than that, you have to, on the newer cars, you're going to have to, on the rear differential, you can look to see if there's an electronics component on there to the differential. If there is, you have the locker. If there isn't, you don't have a locker. Because it's electronically controlled, you can look for the solenoid on the rear differential to see if you have an HD package.
And can you also see on your info display that they've got, if you're in a mode, that
No.
there'll be a locker?
No.
No?
Because it shows that the locker's there on the screen, but it'll never engage it.
Oh, really?
Yes. Yes.
You did the software universal, and then if you have the, if you got the HD package, it plugs in and activates the screen. Nice.
Gear oils. I use what the manufacturer recommends typically. In Discoveries, older cars, I will use a thing called Redline Shockproof Gear Oil. I'm plugging Redline, a Redline Shockproof Gear Oil. Okay. It is a cushioning gear oil. It runs in the car like a 7590 or 75140 gear oil, the lightweight stuff. But it actually has a cushioning properties like a 300 weight oil. So it's basically protecting the gears. It's protecting that, right? It's a full synthetic gear oil. It keeps, basically, you use it in there, you almost can't feel that clunking from the differentials when you put it in there. It makes a world of difference. In things with limited slips, there is a limited slip friction modifier that you either comes in the fluid or you can buy as an additive to add to the fluid that you're putting in there. Your transfer cases, the electronic transfer cases with the locker in them, they take a special fluid called BOT. Land Rover comes with these little plain bottles and you have no idea what really is in there. It's the magic stuff, right? But they call it BOT fluid. So the transfer cases on the LR3s and newer do take a special fluid. The Borg Warner older transfer cases would use ATF, transmission fluid in them. Some of your transmissions manuals take automatic transmission fluid in them too. The differentials, if you're on road, you can run a nice just regular synthetic gear oil. Almost anything will do. Gear oils and stuff out there today are pretty phenomenal. Quality of everything has gone, technology's brought things, made them better. When I'm off-road, though, you need that extra protection. This might be a little bit of movement, but to a couple thousand pounds being put into that, that's a lot of movement. The other thing you get is deflection in there when you're putting that much force in there, which is the amount that the bearings will allow this to flex. And you're flexing steel, but it'll flex, and you get deflection of the differentials on there. So running a thicker fluid in there does help a lot when you're off-road. I think that's pretty much it on. Any questions on gear oils? Pretty simple. Traction control, ABS. Talked about that. Traction control. the picture, that went out on the picture that's on the website of me in that Discovery, the black one, only one wheel's on the ground. If you guys ever look at that, the other wheel on the right front is sitting, it's touching on the side, but the car is literally sitting on one wheel. Only one wheel had traction. I did that on purpose as a joke, fooling around, right? And it just happened. There's a good video of it actually spinning all three wheels until the traction control system figured out that that wheel was the one that I needed to move. And it did. And it was pretty damn quick that time too. Okay. I think that's pretty much it. We've talked about traction. We've talked about how to save axles, where the power is going. We've talked about differentials. Does everybody get it?
Yep.
I got a lot of head shaking, yeah, okay.
I got more than I had when I got here.
That was the goal, right? Oh! There is one more piece of this puzzle. Okay, so traction control, lockers. Tell me what is the most important part of your car? Is it?
The tires.
Tires. The tires are the most important part of the car, especially off-roading. Traction is only applied through the tires, right? So, people go with really gnarly tires for traction. No, you don't need gnarly tires. You need tires that work. On pavement, you need sticky tires. But you need tire, you know, if you're drag racing, you want something really sticky, really big, wide, lots of footprint. When you're off-roading, you don't per se want a big gnarly tire. You want something that has a lot of design to it. An all-terrain is typically the right tire for the job. An all-terrain tire does kind of the best of all worlds. The tire construction has a lot to do with it. There's some tires out there that have multi-stage construction. So the inside, as the tire tread wears, they actually get stickier versus the outsides, it's harder. I think Bridgestone was doing that with the Taranzas, if I remember correctly, back in the day. So tires are the most important part of traction, period. They are the most important part of the car, period. I will say that point blank. You can't argue with that. You gotta stop the car, it's the tires doing it. Brakes are working it, but the tires are what are stopping the car. The traction is what's stopping the car. You gotta go over a rock, traction control's working. It's all about the tires' contact to what it's on that makes the difference. So, with that being said, the most important part of traction is suspension. Lifting the car is not going to give you better traction, gives you better clearance. Overspringing a car limits the amount of traction you're putting on the ground because you're now too stiff. So travel in the suspension goes back to traction. The more you can keep the tires on the ground, the better traction you have. The more footprint of all four tires combined on the ground equals better traction. So when you are building a vehicle to go off-road, you have to think about everything has to work together. It all works together. It all intertwines. but you want to think about the movement. Land Rover did a really good job with the LR3 because they would, when they brought it out, because they were simulating articulation in the vehicle. They could actually lift this wheel, reduce the pressure in this wheel while putting pressure in this side, so that the wheels with the air suspension, you still get to travel, right? We tend to take it out of there for reliability by putting coil springs in there, because air suspension has a lot of moving parts and things break and it's expensive, right? So we mitigate one factor by fixing another, and we kind of lost a benefit over here. But you have to think about the overall picture and what's going to get you home also. So when you're thinking about suspension, think about how much footprint can you put on the ground to gain traction. And so when I do build cars, I always think about the movement. How much is that movement going to keep the tires on the ground? The more that you can keep the tires on the ground, the better it is. And that's another reason why I say lower the car. If you can get through the obstacle with the car at a lower point, drop it down, because what will happen is, one, you're giving it more strength in the axles, but you're also creating more articulation for the vehicle to use. So when you're dealing with an air suspension car, if you can lower the car down a little bit more, you will, one, strengthen the axle shafts, which is the weak point, and you will give yourself more ability for traction, for articulation. Sadly, with LR3s, we're all trying to get them up in the air, and we put coil springs on there, and when we do that, we overspring the suspension a lot of times. And by doing that, you don't get any movement out of it. But you're trying to deal with all the weight that we've stuck on it, and so we overspring them, which is really common. But there is no good way around that. You have to deal with the weight, give and take. So, you know, that's basically it in a nutshell. I think that's, does anybody have a question? Come on, ask me a question.
So, you're saying when your car is lower, you have more articulation. So you're thinking the articulation is all downward, you're getting more downward articulation? Because I thought when you raised it up, you allowed more upward articulation.
So you want to give the car a happy medium. By lowering it, I don't say lower it down to its lowest mode. I'm saying lower it back down to like regular ride height. You want one wheel to be able to travel as low as it can. If we're going through a you want this wheel to be able to travel up as high as it can. So more air pressure you have in there in the system, the less upwards movement it can do. Okay, so if you lower it down a little bit, it allows that wheel to come up a little more, is the thought process on it. So you want to find that happy medium, but you're also worried about your axle strength. So the higher you go, the weaker the axle is. Once you go over 4 inches, you're going to break axles, period. You're just going to snap the front axles on there. The angle from the factory, it's already at an angle because they can't run them straight, right? You don't want to ever run them flat straight because you just wear grooves in where you're at. So you move them off center so that things move back and forth and you keep things happy. So by lowering it down, you're strengthening your axle, but you're also allowing the suspension to move because there's less resistance, less air pressure in the system. You know, the higher you go, the more air pressure is in that bag, right? So by lowering it down, if you can, lowering it down, there's less air pressure in there. There's more movement available. So.
Yeah, when you're up high with the airbags, it's like, you notice it's like a pogo stick.
Yeah.
It's like super bouncy, you know, not because compliant.
Yeah. Yeah, more pressure you put in there, the more everything has to work to keep itself happy. Like your shocks have to work harder because now you're putting more pressure for it to resist. You know, so you know, the more you spring up, like, the more you lift a car. Lifting a car is not the answer. Like you know, you want to go climb over an obstacle, right? Lifting the car is not usually the answer. It's making things move, right? It's about movement. It's all about movement. The more movement you can create, the more traction you have, and the happier things are. So it's, you know, the suspension is not just about putting the car at a height. You know, it's there's a lot more to it behind that, as far as what it needs to do. So, and sadly, I am my own bad guy. I've done it myself. I've oversprung many LR3s, LR3s and LR4s, having to put, you know, you throw so much weight on them that you have to put an SYA kit on top of a heavy duty spring set. That car is way oversprung. But you've got the rooftop tent, you've got steel front and rock sliders, you got steel bumpers, you got a winch. Huh?
Drawers.
The door, yeah, drawers, yeah. All the gear you put in the back. You're so much weight on there just to hold the car up. You have to overspring that thing. They don't. What would be ideal is if they made even more spring options, and they don't. Right? They don't. So you're kind of stuck with working with the limitations that we have available to us, and we thought about that though. I almost had us an option for it, for coilovers for them.
There's a guy actually I saw who did prototype coilovers.
I was working on
chargeable
it years
like
ago.
No, he still has them. They're green, but they're like your Fox system.
Yeah.
The reservoir.
Yeah.
With a reservoir system. Yeah, he's prototyping now.
I was working on it years and years and years ago, and I ran into a brick wall and with the people that was helping me, and I was like, that's it. I think that's it. Let's wrap it up.